Welcome back, everyone, to episode 11. My question for you today is, how would you program Snake or Uncle Worm or whatever you want to call it? How do you make that program if you had to program it? In fact, more specifically, where would you store the information of the snake? Would you store it as a list of particles of the snake, where each particle has an x and y coordinate? Or where would you store it as a grid of possible states where either there's snake there or there's not snake there? Well, there's two things you're going to have to do with the information of the snake. You're going to have to create more snake at the head of the snake, and you're going to have to delete the old snake at the tail, which means you're going to have to remember where the entire snake is. But you also need to detect whether you're intersecting your snake anywhere, which means if you stored it as a list, it would be easy for you to find the tail to delete it, but it would take a long time to search the list to see if any coordinates match where you're moving to. So actually the answer to the question is both. You store both of them, and that's exactly how I always programmed my snake games. I always used both of those. Now I remember showing you this game, but we're going to look a little more in depth into it right now. Here's where I set my x and y coordinates. I set the length to be 4. I just use another variable m. This is a little more complicated than just a trivial snake because I keep track of, I believe, like the total lifetime or something like that, or not sure what exactly m was. But here's where I create a matrix, and I set some states of these variables, C and D. We'll see what those are later when we look at the code more. Looks like D is a counter for where we are, because right now I'm accessing part of the list based on D, which D is probably some kind of counter to where let's say the beginning of the list is the left side of the screen and the end of the list is on the right. Well, if the list needs to get larger and smaller, I don't want to have to shift all the information in the list. I just want to, make it longer or shorter, but still, keep everything in the same spot, but still be able to just wrap to the front, as if the list was more like a circle rather than just a line. So D must be like the position, on the circle where that is. Let's see here. I think random number generators for R and Q and S and T, I think those are probably the generation for certain things like food or traps or something that appear in the background, because that's really the only thing that's random. So here you see T and S are a piece of food, and then here's a double piece of food, which counts as more. It counts as more food when you actually eat it. I'm not sure what this means. If A equals 25, so this means if you're pressing up and Z does not equal 1. Okay, so I think if you're not going down already, so Z I think is the direction you're going. So if you're going down, then Z is 1. So if you're going down, it will not let you go straight back up, because otherwise you would just kill yourself, and it's kind of inconvenient to die in that way. So I made it so it's a little harder to die in that sense. So yeah. So I know I already programmed this in the past, and it still is on my calculator, but we're gonna try to, make, I guess, another snake game. So we're gonna try to just mimic that, but we're just gonna make a simple one, just as like a kind of a, I guess more like a tutorial. So if you've never programmed Snake before, I'm just going to call this one Snake 2. And we're just going to make a really simple snake game. So let's go ahead and clear the screen. Let's set our starting positions as 4, as I'm used to doing. And then let's use matrix A for the entire, the large matrix. So 816 stores the dimensions. Then we want to obviously do the usual fill it with 0. Okay, so now we have a full 0 dimension background matrix, and we don't have a snake yet, but let's go ahead and make snake. So let's go ahead and use list 1 and list 2 for the coordinates of the snake. So list 1, let's make that the x, and list 2 the y. So let's actually put x and y into it. That way, in fact, what we could do is we could make the length of the snake 3. So let's go ahead and store 3 into the length of the snake. We'll just use L for that, I suppose. And then I suppose we're ready for the actual loop. But before that, we gotta output where we are, because I want the loop to just output new segments from now on, so we don't have to worry about old ones. Let's go ahead and set. Let's also set 1 into that part of the matrix. So matrix A, yx, and of course this is yx as well. We're going to store 1 into it. That way we don't. That way we're not, we're not hitting any. We're not. We can, when we program the loop here, we're not gonna set the matrix to be 1 in this position, because we're gonna be moving after that. So from the beginning on, we're just gonna be moving. We're only gonna be setting the matrix in new positions. So we want to pretend is that somehow all 3 of our snake pieces are in 1 position. We're alive, so that's 2 things that we're starting off. We're printing it off to the screen, so that's 3, and we're also in that actual position on the matrix. And also we have this setup. So basically just starting everything off with 3 snake segments, and just pretending that they can exist in 1 spot, which they won't be able to after we move. So let's go ahead and set. Let's go ahead and also set one more thing before we get in the loop, and that's going to be our direction. And let's use D for that. So let's say direction 0. Let's say that's moving to the right. So let's go ahead and we'll have a loop, or we'll have inside the loop we'll test if D equals 0, then we're going to add 1 to X. If D equals 1. Let's go ahead and subtract from x. If d equals 2, let's add 1 to y. And if d equals 3, let's subtract 1 from y. So there we go. We have snake directions. We're at our starting position when we move or change our coordinates. We want to test if it's okay for us to move. In fact, we might as well what we could do is I could just delete this, or no, you know what? Yeah, we could put this inside the loop. So we could do this at the start of the loop. Oops. And then we'll just store D up there. So that way we're outputting right off the bat where we are. So basically we're starting as a non-existent snake, and then we're just kind of, at least on the detection grid, and then we're going to basically just exist there. So we're going to, as if we just moved to the position 4, 4 for start. And then after we move, we have to check if we're out of the screen. So let's go ahead and do this. Okay, so basically, you'll notice that we're not moving based off the get key. We're moving based off the variable, which is set based off our choosing of the get key. So there's no way for us to stand still. We're just going to be stuck in some direction or another. So the only thing we can do is change the direction. We can't stop. So if A equals 26, that means we're pressing right. Then what we're going to do is we're just going to set D to 0. So 0 stores D. And then if A equals 24, 1 stores D because that's left. If A equals 25, we're going to move, I guess down. That's up. So let's do 34 first because that's down. So 3 stores D would be actually equals 25. So yeah. So we should be able to, let's go ahead and go to snake 2. Okay, so I can move around and it wraps the screen. This is good, this is good. So yeah, this appears to work. But you'll notice we're just drawing all over the screen. So obviously we need to erase ourselves, but in this case, erasing ourselves is erasing, of course, the last position in the list, which means we actually have to use the lists, to get that in the first place. And we don't want to shift the list down every time, because once the list gets, like, let's say the list is 20 units long, we don't want to shift 20 units just to move one space. The program's going to go really slow. So instead of doing that, we're going to define where the start and the end of the lists are. of the list is. And the start of the list, so I'm going to use another variable here just to define the start of the list, and it's going to be C. Okay, and that's going to be here. And then I also need another start of, I need another variable to keep track of the size. Actually, no, we already have 3 for the length. So we do have the size of the list. Okay, so yes, so our size is 3, our count is 1, and our direction is 0. Okay, so we want our count to increase. So we want to store this actually, I'm going to come down here at the bottom, and I'm going to take X and Y, and I believe X was L1. Yes, so we're going to store X and Y into L1 and L2. And we're going to store those at count. Okay. And then, so those are going to be printed out, but we're not going to use the list again until we're erasing ourselves. So let's go ahead and we can go ahead and change C, because we're just going to be using X and Y, before we change them again anyway. So I'm going to store 1 into that position, because of course we need to mark our territory where we've been. So YX, and so we marked both the list and the background. Of course, if matrix A y x equals 1 before we even set it to 1, that means we were already there. So we actually we need to die at this point. So I'm going to stop the program after I display death. Okay, so basically if we hit into ourselves, we die. And then after we set this new position, we need to erase our old selves. And this is going to be a little different. So we're using C, which starts off at our length. We're using C to mark where we're drawing to, which means the opposite end of the list, or the part that's basically comes right after C. That is going to be where we're erasing from. So I think we'll use B for that. So C plus 1. Actually, you know what? For now, let's just increment C, and then if C is greater than length, then we'll just set 1 into C. So that'll kind of like restart us. That way, that way we can go ahead and erase ourselves. So we're going to draw a 0 in list 2, C, list 1, C, we're going to put a space, and then we're going to set a 0 into that matrix. So matrix A, list 2. Of course, I might be able to make this go faster by storing these, because accessing a list actually takes a little bit of time. So if I store those into variables, that would be quicker. But anyway, we're setting that to 0. So let's see if this works. Okay. So if I turn too fast, I should die. Or if I go into myself, yes. So if I went backwards, I died. Okay, so we should be able to change the length of the snake. So if I come down here, so let's go ahead and set the initial length here. So if I do, like, let's say 15 stores L, so we're going to make a really long snake. For here, I'm going to replace this right here with a loop. So I'm going to replace this with a for loop. I'll just use A, for A is 1 to L. And then I'm going to set, I'm going to delete the variables actually, so that we clear extra memory that we don't need. So let's go ahead and go to delete var and do that twice. We're going to delete list 1 and list 2. And then what we're going to do is we're going to store X into list 1 sub A. And we're going to store Y into list 2 sub A. So we're going to run snake. And now our snake should be 15 long. So if we run into ourselves, we die. So I can tell the matrix will look exactly like our snake because I'm not dying when I'm going back over our old snake. So I know it's working properly. So if I just quit here and I show you matrix A, you'll see we have 1s right where our snake was. So I mean, we can see that it's just by how the game runs, you know, that everything's working properly. Now the trickiest part about this program has not yet come. Sad to warn you about this, but actually there is a tricky thing with the lists that you have to be careful of, and that has to do with resizing the lists. So if you get larger or smaller, it is actually kind of complicated what happens. And even if we just get larger, even if we're just playing regular snake and we eat a dot, there is something that happens that we have to be careful of, which means I might actually have to introduce another variable to stand for our capacity or something, but I'm not sure if the capacity will only be needed for if our list is I don't know if we only have to do that if our list shrinks as well. So let's go ahead and since we already have everything working, yeah, let's go ahead and we'll choose a random integer from 1 to, let's say, 10, and we're going to store that as I guess we can use B because we haven't really used B, we've only used C so far. And if B, let's use 0 to 10. So if not B, so there's a 1 in 10 chance that we're going to do this next line, this next couple lines of code. So if there's that nice chance there, okay, and then we say and, or well, no, then we choose, we need to choose random coordinates. So I'm going to choose from 1 to 8. I'm going to store that as T. And then I'm going to choose 1 to 16. And I'm going to store that as S. Now even further, I'm going to do another test. So if matrix A TS equals 0, then this gives me the opportunity to do what I'm going to do. Okay, so I want to make sure I'm not drawing over. I'm not going to, what I'm trying to do is I'm trying to put a piece of food somewhere randomly on the screen. But see, what I've done here is I've tested, I chose a random number between 1 and 10 to see if I'm actually going to do it. So it doesn't happen too often. Then I choose a random coordinate to where I want to place the food. And if it just so happens to be that there's no place to put the food there, if there's already a piece of the snake there or something, then we'll just move on. We're not going to try to place the food anymore. So we have one chance to see if that random position will give us an opportunity to place the food. That way our code doesn't get stuck just trying to place food all the time. We'll just give it, a chance every once in a while to see if it can try to place a piece of food. So if it can, then what we're going to do is we're going to store 2 into that position. And the 2 is going to represent the food. And then we're also going to output, we'll make it a dot. So now we have this kind of like dot thing. And right now, the way the game works is we will just run over these dot things and they won't really do anything. Oh, I died because I ran into myself. So right now it looks like plenty of them appear, but I'm not going to be getting any longer because I'm not increasing my length by eating them, and that's what we're going to do now. So let's go ahead and increase our length by detecting whether we ran into and detecting if we actually ran into one. So here we detect if we ran into ourselves. If we don't, then let's go ahead and check for food. So if we actually run into food, let's do 2 because that's food. Then we're going to do whatever's in this test statement. So if we run into a piece of food, then we want to increase L. The problem with this is we might get a bug, because if we just simply increase L, something like this happens. So what we need to do is we can't increase our length right away. We need to increase the potential for our length, because what's happening is we have two lists. So we have like a list where we have our x coordinates here. Let's just focus on our x coordinates. Forget about the y. Let's pretend this is a list of our our somewhat random, x coordinates for our snake. So maybe they're closer to each other. So maybe it's 2, 2, 3, 3, 3, 4, 5, 5, 5, 4, 4. Okay, so let's say these are the x coordinates. And let's say I add to the length of the list. So now something can go here. Okay, but let's say the head of our list is, here, and the tail of our list is here. But we just added 1 to the length here. So the tail's going to keep going. Well, I guess this would be the head and this would be the tail. But the tail's going to keep catching up, and then the tail thinks that this spot right here was actually, part of the snake's body, but it never really was because the head never wrote to that position. So what we have to do is we have to make the tail wait until the head actually gets to that position to use it. So this is where it gets this is where the tricky part comes in. So I'm gonna go back to our snake, and you'll notice when we actually play it that the snake won't get longer is the instant that you eat a piece of food. And that's because of that whole list thing that I showed you. If the snake, is it still on the screen? No, it's not on the screen. But if the snake, here I'll show it again. If the snake tail, once the snake head gets to here, then the tail will be delayed by 1. And then you'll actually see that the snake got longer. You won't see it until it actually reaches the end here, and you actually have, until you actually have the head of the snake here, and then the tail, the tail can move. The tail stays there for 2 iterations, because before that iteration you have the head here, and the tail has already moved there. Okay, but then the head knows that it can use up 1 more spot, so then the head moves there, and then that's when you actually see that the snake gets longer. So that's the bug that I was talking about. And once we overcome that bug, then there's not really anything else confusing to this, and we have a full snake game after that. So let's go ahead and let's figure that one out. So but the thing is, we will need another variable, because there's another thing I forgot to mention with this. So let's say these are the x coordinates, and let's say the head and the tail are like right here. Let's say you eat like 3 pieces of food in a row, with the head only moving. Let's say the head only moved up to, like right here by the time you finished eating those. Well, the tail's gonna have to, the tail's gonna have to sit here and wait for the head to go all the way to the end here. So the head's going to be moving along until he finally reaches the full capacity. So that's what I was talking about when I was talking about the capacity. I finally remembered what specifically it was. But yeah, the capacity, so I'm already using C for the count. So in L, so C is like the index of where the head and the tail are. But we need something to keep track of how many new pieces of food basically that there are. So we have a 15 stores L, but what we can do is we can also store L into some kind of capacity variable, something that so since we already used C for capacity, I'm going to use M for max, and I think that's why I had an M on the other one. I think that's what the M stood for, was a maximum. Now that I'm programming this, I'm like deciphering my code for the other snake. So M is going to be our max, and usually M is going to match L until we eat a piece of food, and then usually M should just be like 1 ahead of L until L can catch up. So we're not going to increase L by 1. What we're going to do is we're going to increase M by 1, which is safe, because we're not going to increase L right away. The tail's going to be looking at L, but the head is going to be looking at M. And then when the head writes to it, then we can increase L. So, so here we write to it, to the background. Here we increase C, so this is our count. So I'm kind of doing this weird thing where I'm increasing C and using C as both the head and the tail variable, which is okay. In a sense, but when you have like 3 pieces of food that you've eaten in a row, it doesn't really work because the head will actually have to be, you know, at those last few positions, filling up, you know, till the list is at its max, while the tail is still just at 0. And we don't want to lose the information of where we are at the head, so we can't just increase it, and if as soon as it's greater than L, then we set it to 1. We can't really do that. So what we can do is we can increment C. I think that's okay because we will need to increment it. But we don't want to store 1 into C just because C is greater than L. We want to do that if we want to store C into a new variable that's going to be the tail. However, this kind of introduces another strange bug, which means the tail's going to be stuck at the same position for a while, which means if we actually run over where our tail was, it's just going to erase that one part of our body, I think. But I don't know if that really matters. Anyway, we're going to store it into, let's say E. Okay, so E is going to be for our tail, just because it's next to, I don't know, we'll use F because it's right next to C. So we're going to increase C. If F is greater than L, it doesn't really matter if we say if C or F because they're the same at this point. But the point is we want to set 1 as F. We only want to set 1 as C if it's greater than M. So if C is greater than M, then we want to set 1 into C. That way, you know, we're going to our full capacity. So C is using up, you know, the capacity of our of the snake, but we want to increase L. So now that we know the tail is safe if it needs to be, we can set the new size of our snake. So basically we can say if C is greater than L, actually hold on a second, let me double check something. Okay, so we're increasing our max. We're storing 1 into whatever our x and y were, which is fine. Where do we actually set our... Where do we actually set our lists? I kind of forgot. Where do we set... Oh, here we go. Okay, so X and Y store is C. So list one. Okay, so X and Y are stored at the current C. Okay, so we're just setting up C for the next time, for the next iteration. So if yeah, so if C is greater than M, yeah, so that means if C we don't want to increase the length unless we know we've written to that though. So it would be here that we would say if C is greater than L, then C stores L, because here we know that we're safe in whatever C is, we've written to it for sure. But setting up for the next C, I don't think is the safe way to do it. So this is after we increased C, then we find we're finding the new head and the new tail at this point, but we're not updating the size of the list at all. We're just updating the head and tail based off our max and based off our max for our head and our tail. So I believe this should work. So we have 15. I should be able to just eat a piece. And then, oh no, this is not good. List 2C and list 1C. Okay, let's see what list 2C is. I believe it's too small for it, that's what it is. So what's C? So C is 16. List 2 is, I'm going to say the dimensions of list 2 is 15. Well, actually, where did it get tripped up? I'm kind of curious now where it actually got tripped up, because we shouldn't be accessing Oh, I know why. I'm sorry. Perfect. So of course it shouldn't work because we're actually because I'm trying to erase using the variable C still. I forgot to update this to an F. So good. There's nothing. I believe there was nothing wrong with our the code that we just made. I didn't remember to upgrade our variable, which variable we were using for the erase. So. Oops, killed myself there. See, it's already a challenging game, and we've only worked on it for like an hour or so. Did you see how it paused for a second to get longer? And there we go. That is a fast, efficient version of Snake that uses two different data structures to store the snake. One for the snake's coordinates as per the position on the snake itself, and the other for the snake's existence per the coordinates of the world. So we can wrap the screen, of course, and we can get longer, and we can actually detect how long we are. So one thing to do the way we would do that, just to top this off before I finish up, is I would use M. Because M tells you how long, how many, M is related to how many food particles you ate. Of course, you could judge it, any way you want. Any decision on how you would, but L doesn't necessarily upgrade or update instantly. So if you want to know exactly, 15 plus how many food you ate, you would just, display M. So I could just say, display, length, and then I would tell them that their length was M, because M is like, I guess, the ideal length, and L, even though we called it length at first, L is more the actual length that the data structure is able to put to the screen at the time. So M is actually the length that we're shooting for. We just use L because we can't get to M fast enough. So there we go. We have death, and our length is 24. And that, my friends, is a simple version of Snake. I hope you enjoyed programming this at home, and you make your own alterations to it and your own expansions to it. Maybe you can combine this whole, going to the edge of the screen thing and make like a large snake, which actually wraps, 4 different screens by combining this with our Zelda idea of making a bigger world that just keeps going in one direction. So I hope you enjoyed this and you build on it and you have fun making your own snake games. And that's all I got for today's episode. Have a nice day.